Hello my dear students, once again welcome to your online class. Hope you are following with the videos that are being uploaded in the YouTube channel of Bone English School. And if you haven't, please revise once again all the formulas of derivatives so that we can move on to the chapter of calculus. So in the reduced syllabus, we have one more important topic, that is the L'Hospital's rule, or which comes under the topic of indeterminate form of limit. Okay, so what is this indeterminate form of limit? Like if I have any function, okay, like if I have any function f of x, okay, and if at a certain value of x, like when x equals to a, if it takes the form 0 by 0 or infinity by infinity, then the function is said to be indeterminate at x equals to a. Like for example, if I have the function, okay, which is f of x is equals to sin x divided by x. Now if I substitute the value of x equals to 0 in the given equation, so I will get sine of 0 divided by 0. Okay, so sine 0 is 0, so 0 by 0. So thus I can say that the function f of x, that is sin x divided by x, is indeterminate at x equals to 0. Another I have, like if I have the function f of x is equals to log of x divided by cot of x. Now if you try to evaluate the value of this function at x equals to 0, so log of x or the log of 0 is equals to undefined, and cot of 0 is also undefined. So this is the form infinity divided by infinity. So it's also known as a indeterminate forms. Okay, so all these kind of functions are known as indeterminate forms. Now coming to the L'Hospital rules, so you must be knowing what is limit, right? We have done it in class 11. So once again you revise the chapter of limits. So the L'Hospital rule says that under certain conditions, okay, provided under certain condition, the limit of the quotient of the two functions, that is f of x divided by g of x, where f of x and g of x both are the function of x, is determined by the limit of the quotients of the derivative. Okay, so in certain cases, when the direct substitution of the limit, it gives the form 0 by 0 or infinity by infinity, what we can do? We can find the ratios of the derivative. Okay, like if I have the function, okay, like if I have a function f of x divided by g of x, okay, suppose at limit of x tending to 0. So suppose if when I make a direct substitution of x equals to 0 in this limit, maybe it comes in the form of indeterminate form 0 by 0 or infinity by infinity. But what can I do? So I can also write this one, it can be easily evaluated by the derivative of those functions f dash x divided by g dash of x. So that is what is the L'Hospital rule. And remember, there in the L'Hospital rule you will not imply the formula, it is not d by dx of f of x into g of x. It is not the derivative of the two functions u by v form, but rather it is the derivative of the individual function. That is, I will write limit of x tending to 0 d by d of x into f of x divided by d by dx of g of x. Okay, so this is what is the L'Hospital's rule. So here I have taken one example. So let us try to understand the L'Hospital's rule with the help of the simple example. So here is given that find the limit of 1 minus tan x divided by cos of 2x when the value of x is tending to pi by 4. So if you directly try to substitute the value of x as pi by 4, so what they get? So tan of pi by 4, that it is tan 45 is equals to 1. So 1 minus 1, it is 0. So here it will be cos of, so if you substitute the value pi by 4, it will cos of 90 degree, again 0. So this comes under the form of, so this comes under the, so I can write that limit of x tending to pi by 4, 1 minus tan of x divided by cos of 2x. It comes in the form of 0 by 0 form. So now what can you do? We can apply the L'Hospital's rule. So applying L'Hospital's rule. So what does the L'Hospital rule tells? Like it is the limit of x tending to pi by 4, 1 minus tan of x divided by cos of 2x will also be equal to limit of x tending to pi by 4 and the derivative of this one. So, it is d by dx of 1 minus tan of x divided by d by dx of cos of 2x. Okay, so, let us see what we get. So, this will be equals to limit of x tending to pi by 4 and then there I have 1 minus what is the derivative of tan x? The derivative of tan x is tan is sec square x, it is sec square of x. So, divided by what is the derivative of cos 2x? It will be minus sin of 2x into 2. Okay. Oh, sorry, the derivative of 1 is 0. So, I will not write this. So, simply I will give. So, minus and minus I can cancel. So, this will be equals to limit of. So, now what will I do? I will try to put the value of x equals to pi by 4 now. So, if I put pi by 4, so it will give me the sec square of pi by 4. So, what is the cos of pi by 4? It is 1 by root 2. So, sec square of 45 will be equals to, it will be root 2 square, okay, divided by, now what will be the sin 2x? So, if I put the value of there, x equals to pi by 4 into 2. So, I will get it as, so let us say what I will get. So, 2 comes in the front. So, I will get sin of 2 into pi by 4. So, this will give me divided by 2 divided by 2 will give me pi by 2. So, sin 90 is 1. So, it will give me 2. Okay. So, root 2 is, it is 2 divided by 2 which will give me 1. So, this is how we evaluate the value of the limit of the certain functions which are of the indeterminate form. Okay, so, in the reduced syllabus we have only the indeterminate form of 0 by 0 and undefined infinity by infinity, and the value of limit of x tending to 0 log of sin 2x divided by log of sin x. So, if you see here, if I make a direct substitution of x equals to 0, so sin of 0 will give me 0. So, log 0 is undefined infinity. So, this is of the form infinity divided by infinity form. Okay, so, in this case what can you do? So, I can apply the L'Hospital rule. So, I am applying L'Hospital's rule. Okay, so, this limit of x tending to 0 log of sin 2x divided by log of sin x will be equals to the derivative of or limit of x tending to 0 d by dx of log of sin 2x divided by, okay, whole divided by d by dx of log of sin x. Okay, so, therefore, I will get differentiating, I will get limit of x tending to 0. So, the derivative of log of sin 2x is equals to 1 by sin 2x. Okay, now again I need to differentiate the sin 2x. So, the derivative of sin 2x is cos of 2x into again differentiating 2x, I will get 2. So, divided by, in the denominator, the derivative of log of sin x is 1 by sin of x into derivative of sin x is, now it is cos of x. So, this will give me limit of x tending to 0. So, cos by sin theta will give me cot. So, it will give me 2 cot of 2x divided by, so here it will be cos divided by sin will be, this will be cot of x. Okay, so, now if you see here, if you make the substitution of x equals to 0 here, so it will give me cot 0 divided by cot of 0 degree. So, again which is of the form of infinity by infinity, or what you can also do, you can apply the L'Hospital rule there itself, or this also I can write as limit of x tending to 0. So, instead of cot 2x, what will I write? So, 1 divided by cot x will be equals to tan x. So, I will write tan x in the numerator. Okay, so, 2 tan x there. Okay, and cot of 2x I can also write it one as tan of x, tan of 2x. Okay, so now again this comes in the form of, so tan 0 divided by tan 0. So it will give me the form of 0 by 0 form. Okay, so if it is so, you can go on applying the L'Hospital rule until you get the form, you get the case when you make a direct substitution of x equals to 0, the value does not becomes indeterminate. Okay, so again I will applying the L'Hospital rule. So applying that L'Hospital's rule. So when we apply this one, so again this I'll get limit of x tending to 0. Now the derivative of 2 tan x will be equals to 2 sec square x divided by, here I'll again get, so it will be sec square of 2x into 2. So this will give me limit of x tending to 0. So 2 and 2 get cancelled. So sec square x divided by sec square of 2x. Now again if you make a substitution here, okay, sin sec of, like if you make a substitution of x equals to 0 here, so what you will get, you will sec x, that is sec 0 divided by sec of 0. So sec of 0 we know it's equals to 1. So this will give me 1 divided by 1, which is equals to 1 itself. Okay, so this is how we apply the L'Hospital rule to evaluate the limit of the form 0 by 0 or undefined by undefined. So dear students, you may do such questions which are related to the L'Hospital's rule only in the case of 0 by 0 or infinity by infinity. So in the reduced syllabus, you do not have to go for a Rolle's theorem and a mean value theorem. So all that you have to do in this indeterminate form is the L'Hospital's rule of the form 0 by 0 and undefined by undefined.